Hey everybody, so in this tutorial we're going to go through doing analysis of variance or ANOVA by hand. What this means is in Excel we're going to go through and calculate sum of squares, mean squared, degrees of freedom, and we're going to determine how we get the output in our ANOVA table. So let's just go straight into Excel, and I've got this data set up like this where we've got salaries in millions of dollars for the top 10 NHL players from 2017, 2018, 2019, and 2020. So one of the first things we want to do is calculate group means, because what we need to do is determine the variance from the group mean. So first thing is we're going to calculate means equals average of those. And I'm going to do that just by dragging this value across. It'll copy over that formula. So I've got means for each of the years. We also need a grand mean. That means a mean of all of the values for the entire table. And we're just going to put that in this spot right here. So equals average all of these values. Okay. Now, in order to calculate our model sum of squares, which is down here, that's this chunk represented with the red box. What we need to do is calculate our squared group differences from the mean. So we take our each group mean, subtract it from the grand mean, and square the value. So that means, in this case, we're going to say equals this group minus this value. We take that whole thing and square it to the power of 2. There we go. Now, in order for me to be able to drag this across, what I need to do is I need to make this an absolute reference to G15, so it doesn't change when I move it. I can do that by pressing F4. We can see it puts little dollar signs in front of that, which means when I drag this over, the first part of this equation drags over with me, but the second part stays put. That's what I need. So I can just drag that up. So now I've got my group differences from the mean. Now, the next thing I need to know is the number of observations in each group. Now, I know it's 10. Another way I could do that is just by saying equals count, if I didn't know how many were in it, and grab the list. So I can do that, grab 10. Drag that over. And now I just multiply the squared group differences for the mean times the number in each group to give me my total. So equals that multiplied by that. And drag that over. Finally, in order to get the sum, I just want to take the sum of all of those. Drag that over, hit sum. Now, what we can see is that's automatically updated this value over here. Now we've got a model sum of squares of 37.62. Okay, good so far. The next thing we're going to do is we need to calculate squared individual values from the grand mean and squared individual errors from the group means. So the way we're going to do that is by using a table here. And the way that's easiest to do this is I know my grand mean is here and my group means are here. So I want to take equals this value, and this is from the grand mean, minus the grand mean. And remember, I can hit F4 so that stays as an absolute reference. And I'm going to square it. And now, because I have held that value constant, that one that I'm squaring against, and the other one gets to move as a reference, I can use all of these and just drag all of those values. And to get a grand sum, which will give me my total sum of squares, that's represented right down here. We can see it's going to put this value into my total, I just need to take a sum equals sum of this entire set. You can see now I've got a total sum of squares of 125.8. Okay, now we need to determine what the residuals are. And the residual error, that's going to be in this blue box here. And again, this is squared individual errors from their own group mean. So our group means are over here, and then the individual errors are going to be differences from them. So in this box, I need to be equals the individual observation minus its own group mean, and I want to square it. Now, in this case, I want the reference to move over with me to the right, but I don't want it to move down. So I wanted to make a fixed reference to row 14, but not to C. So in order to do that, I just need to put a $ in front of the one that I want to hold consistent. That's 14. Now what we see is if I drag this down, all of these are referencing their own with respect to its own group mean. And if I drag this over, it's going to be referencing 2018 for its own group mean as well. So that makes my life easy. I can drag this down, I can drag these over, and take a grand sum again. My grand sum is going to be equals the sum of everything in this box, and this is my residual error. Now what we see is we've got my sum of squares and my residual and my total. Now, I really didn't have to calculate the residual, but we can see that's where it came from. I could have just taken my total sum of squares and subtract my model sum of squares and gotten my residual that way. You only really need to do 2 of these calculations, but we've just shown you how to do all 3. The next thing we need to know is the degrees of freedom for each of these values. So, in terms of the model degrees of freedom, this ends up being the number of groups minus 1. So in this case, I have 4 groups minus 1. My degrees of freedom is 3. In terms of my residual degrees of freedom, that's the number of observations per group, which is 10, minus 1, so 9, times the number of groups, 4. So 9 times 4, that will give me a degrees of freedom of 36. Finally, we see my total degrees of freedom is my total observations minus 1. So I've, in this case, got 40 observations. My degrees of freedom for total will be 39. Okay, finally, the last thing we're going to do is calculate our mean squared. And that's simply our sum of squares divided by our degrees of freedom. So equals sum of squares divided by degrees of freedom. 12.5403. Our mean squared of our residual or error term is going to be 88. So equals 88 divided by the degrees of freedom, 36. That gives me a 2.44. Now we see to calculate our F ratio, it's just the ratio between our mean squared of our model and our mean squared of our error. So that's just equals mean squared divided by mean squared error. And again, F ratio of 5.11969. Now, is this significant? So what we can do is I've given you an F table on the next page. Let's go to that. So if we want to look up our critical value for F, we need our degrees of freedom for our model. And remember, that was 3. And the degrees of freedom for our error term. And remember, that was 36. Now, I only have 30 and 40 here. In column E, that means I'm somewhere between 2.84 and 2.92. So let's just say, for example, 2.88 would be the critical. Well, we know I'm well over 2.88. Therefore, we can say this F value is significant at the 0.05 level. If we want to look that up and find an exact F value, we can do that using the internet or various different ways. The last thing we can do is we can determine what our eta-squared value is, or our R value. And remember, our R value is just simply the proportion of variance that's explained by the model. And in our case, it's pretty easy to figure that out because we've got our sum of squares of our model and our total sum of squares. So in order to calculate this, we just need to put equals sum of squares of the model divided by the total sum of squares, which gives us an eta-squared of 0.299. Okay, that's all we need to do an ANOVA by hand in Excel. Now, if you want to do this by using the built-in functions in Excel, we can do one more step here. So, if we go over to our Data tab and select Data Analysis, I can select ANOVA Single Factor. If I click on OK, it's going to ask me what my input range is. And I'm going to have data that's grouped by columns. So I'm going to select all of my data, including the headings in this case. Click on that tab. And then I'm going to tell it that there are labels in the first row. And I'm just going to ask for it in a new worksheet and click OK. And what you see here is it's created a new worksheet where it's given me some summary data in terms of my averages and my variance for each of the groups, but it's also given me an ANOVA table, which has sum of squares and mean squared for within and between, and there's my mean square and my F ratio. Now we can see my actual p-value is 0.00472. So this is nice that it gives me that exact p-value. We can't do quite as many other things if we do a factorial ANOVA with this, but this is pretty good for getting a really quick and easy ANOVA. But if you want to do it by hand, we've just seen how we can do that. All right, I hope that's given you a better idea of how we do ANOVAs and how we figure out our sum of squares, our degrees of freedom, and our F ratio.